Today's virtual reality systems offer immersive graphics and audio, but physical touch feedback is often non-existent or very limited. Some consumer systems are controller-free, preferring not to encumber the user's hands, but as a consequence cannot deliver any haptic feedback. Other consumer systems use handheld controllers, but even these only generate vibration feedback, falling short of any reality. In this research, we explore an alternative controller-free approach to haptics, where VR applications utilize the user's own body to provide physical feedback, which we call retargeted self-haptics. In this example interaction, a user places their hand onto a palm scanner, which then causes a keypad to flip open. In a typical VR experience, both hands will feel nothing interacting with these virtual elements. However, by manipulating the positions of the virtual hands, what is known as haptic retargeting, we can subtly guide the user's hands together. Now, when the user types on a keypad, they feel an actual physical surface. Note that only one hand receives appropriate haptic feedback, even though this is a two-handed task. We use these two dimensions to form an interaction design space to guide our explorations. The palm scanner and keypad example goes in the upper right quadrant. Other examples in this category include striking a match, where only the hand holding the match receives appropriate resistance, hammering a nail, where the hammering hand is halted appropriately, and cutting vegetables, where again the cutting hand is stopped at the cutting board. It is also possible to have two-handed tasks, where both hands receive coordinated physical feedback that approximates the correct forces and vectors. We built a number of illustrative examples, including this bow and arrow demo, where the user's thumb is targeted to the bow string, allowing the user's hands to exert opposing pulling forces, as would be experienced with a real bow and attention. Here the user can physically feel when the ammunition magazine has been fully inserted by warping the hand positions. In this example, the palm is retargeted to act as a phone screen, and taps to the phone screen exert a downward force on the holding hand. Similarly, the impact from hitting a palm in the hand can now be felt. Not all interactions require both hands, and so we also explored self-haptics for one-handed tasks. As there is only one hand present to receive haptic feedback, the bottom left of our design space is not applicable. While we did consider how a single hand could provide haptics for itself, we found the design space to be much richer when the unused hand was appropriated as an accessory prop. For example, here a user is presented with a red launch button. Typically in VR, the user would just reach out and pull at it with no haptic feedback. With our approach, a translucent hand is also rendered in a scene, which turns green when the user matches the position and pose. Now, with their dominant hand, the user can reach out to perform the one-handed interaction and receive some haptic feedback. In this example interaction, a thumb is used as a prop for a mixing whisk. Here, the unused palm allows the user to rest their finger on a virtual fingerprint scanner. And finally, the palm again allows the user to physically knock on this door. Our aim in this project was not perfect tactile realism, impossible by only co-opting a user's body. Nonetheless, the course Visual-Audio Haptic Fusion helps to make experiences more fun and immersive, and opens new and creative ways to bring haptics into uninstrumented, controller-free VR experiences.